Welcome, everybody. Today's topic, as we said, is virtualized storage for virtualized servers. In today's environment, virtually everyone has virtualized servers. But today we're going to do is specifically target in on the value proposition behind virtualizing the storage behind that and what advantages that would give you. So in our BPIC today in Denville, New Jersey, I have with myself Kara Connolly, who's the client technical specialist from IBM, Gary Landon, who's an executive storage architect, and Chris Avita, who runs our lab and is the manager of advanced infrastructure and hardware services. Okay, so the presenters today that we're going to have, I'm going to be going through, about MicroStrategies, who we are, what we do. My own background is I have 36 years in IT, 10 years with IBM. I did a stint with KPMG for multiple years in their supply chain practice. And in the last 12 years, I've been an IBM business partner specializing in storage. Gary, you want to give a quick...
Yeah, thanks, Dave. Yeah, I'm Gary Landon with IBM. I'm a storage architect. These days, I support customers throughout the eastern United States, covering storage virtualization. Been working with that technology since before it was born, so hopefully you'll get what you would like to get out of the conversation. If not, at the end, feel free to ask questions, and we'll take care of it for you.
Right.
Yeah, hi, this is Chris Avita. I have 25 years in the IT industry, primarily revolving around storage. I spent 11 and a half years with IBM in the mainframe arena, 5.5 years with EMC, and my last almost 9 years with MicroStrategy running the storage and server environment here.
Right. And, from our background also in virtualization, we've been on the forefront of the virtualization from when IBM first came out with it. How many years has that been now, Chris?
Right, it's almost 11 years now, some 10, 11 years that the SAM volume controller first came out, and MicroStrategies was involved from the very beginning prior to it was even announced.
Right, so we've been on the beta, we've been on the WAVE program. So with that said, let me tell you a little bit more about MicroStrategies. Established in 1983. We're an IBM Premier Business Partner. We have a direct relationship with IBM, on our P-Series and storage products, which means we buy directly from IBM, which allows our customers to have, better access to IBM. When we have issues, we go through and we fix them a lot quicker. We're also a top 10 business partner in North America. In fact, last year, we were the IBM Choice Award winner for the top business partner in North America, so that's pretty significant. We partner very closely with Microsoft as a gold partner. We do Hyper-V on the virtualization on the server, but we're also the VMware partner. We do a lot of work with VMware, and we do a lot of work with KVM also. So with that said, okay, the Business Solutions Group, they're involved in business intelligence. We do a lot of application work. We do a lot of database type work. We have multiple technical people that we can bring on site to assist you with that. The Advanced Infrastructure Group, does a lot of work with cloud, server, storage, all infrastructure type stuff, platform services. We go right from the desktop to the servers, to storage, to tape, to backup and high availability, and business continuity planning. Okay. From a storage perspective, we have our Business Partner Innovation Center. We actually have two of them. You're hearing us today live from our Denville one. We also have folks in our Malvern location, and we actually communicate between the two locations for disaster recovery purposes. And we're very cognizant of the following storage platforms from IBM, the V7000. The V7000 actually runs the SVC code that we're going to talk about today natively in it, and we're going to be talking also about the actual SVC nodes and architecture on that. We have the unified SONAS, which it actually allows us to do file structure, and we actually have a SONAS and a unified box. In our Malvern location, we have a unified box up here in our Denville location. The V3700, which is a smaller, more cost-effective version of this V7000. You'll hear more about XIV in other sessions, and N-Series, which is a NetApp box, and the iDataplex for high-performance computing. We were one of the first ones in the WAVE program, also on the PureFlex systems. We have PureFlexes in both of our locations, and we work with integrating the storage into that. It's a virtualized appliance. We'll cover that in another session. We do work with Power boxes, which is IBM's Unix AIX offering, as well as the Intel offering from System X. and we are starting to do some more work on the mainframe environment on System Z. You can go next, right? Okay. We talked about the 2 locations that we have today. I'll leave the chart up there for a second. But really, the value proposition with our business partner Innovation Center is it allows the customers to come in here. This is not any production equipment. This is equipment solely for the use of our customers to do proof of concepts. Our customers can do benchmarking, and allows us to test our solutions before we deliver them to the customers to make sure that when it lands at your location, it's 100% up and running. Okay, next. So at this time, I'd like to turn it over to you. And
all right. Thanks, Steve.
Yep.
And what we'll do is for the next 45 minutes or so, go through a business case discussion of why people look at virtualizing the storage, talk about what the business value tends to be for most scenarios. We'll go through a mid-level-ish technical discussion, a couple of customer case studies at the back end, and then I'll pass it off here to Chris at the end to show you some products, and we'll come back at the tail end of that for any open Q&As that might come out as we go through here. So with that, go ahead to the next slide, please. Storage. Obviously, you guys wouldn't be here if you don't have some storage sitting behind your servers. And I suspect if I ask you, every single one of you would say the answer is you've got more storage now than you had a year ago, and you think you're going to have more storage a year from now than you've got right now. In fact, I've had some fun meetings up and down the East. In fact, actually twice this year, actually once in the last week. Met with a customer executive, and one of the questions I asked them tends to be is, where is storage in your overall IT spend? 5, 6 years, 7 years ago, it was not number 1, 2, or 3 in the overall IT budget. These days, it is not uncommon at all for CIOs or CFOs to tell me storage is either number 1, 2, or maybe number 3 spend in my overall IT budget. And when any line item gets that high in their overall IT spend, guess where they put the bullseye at, right? So while 10 years ago they said, I see there's value virtualizing my storage, but it's not that high on my priority list. These days, it is becoming very high on a lot of priority lists to get their arms around the sprawl spend complexity associated with storage. So, and that's what we're going to talk about. So next slide, please. The generic term I'm going to use here and that we have on this slide is a storage hypervisor. I'm going to try to put this in some context that I think most of you may know something about. Most of you, I'm going to assume, have done some server virtualization at this point in time. Pretty unusual not to find a customer that's not done any server virtualization these days. Whether that virtualization is with VMware, with Hyper-V, with whatever, I'm going to assume VMware for my example and use a VMware as an example because it's probably got the largest market share out there. But fundamentally, what we find out there is that it's certainly that on the server side, VMware has allowed customers to go from an environment where they may have had, literally racks and racks of physical servers and logically consolidate those into fewer virtual servers by doing what they call a physical to virtual consolidation, and now get away with an environment where they're operationally much simpler, cost is much less complex type of environment. Basically, they get their arms around the sprawl spend complexity associated with servers. In real simple terms, think of what we're going to talk about here with the Virtual Storage Center as doing the same thing for storage. This is going to let you take typically multiple physical storage arrays. It doesn't have to be, but typically it is, and start doing a logical consolidation of those into a single environment. Once you start doing that, you simplify a lot of things. Things become a lot less complex, and you start introducing a lot of new concepts in terms of efficiencies and optimization that you can start taking advantage of. So we'll go forward in that discussion. This is a real simple example showing you that up on the top of the environment, how you might have virtualized servers. Right? This is showing like 4-to-1 physical to virtual consolidation on the servers. We're going to talk about today the bottom part of this chart, which is basically the same thing for storage. Those black boxes in the middle of the screen is the actual physical hardware associated with the Virtual Storage Center, or the SAN volume controller component of it. And obviously the solution will consist of multiple of those. Chris is going to show you a demo of the SBC when I'm done talking here in a little while. What you're going to learn out of this thing is that this solution is storage agnostic. Now, while I hope going forward you buy lots and lots of IBM storage, the solution value proposition in the business case doesn't assume there's any IBM storage in the entire environment. You could do this in an environment today that's entirely EMC, Hitachi, HP, Nexsan. You pick your vendor basically out there, and we'll be able to take the existing environment, virtualize it behind the current infrastructure, leverage your current investments for as long as it makes business sense, and then at some point, of course, in time, you'll be buying incremental storage, and obviously we hope you consider IBM at that point in time. So we're going to talk about what this virtualization layer does, and a little bit on the right about how the instrumentation and management of it, because obviously if you're going to put this stuff in play, you're going to need to be able to monitor, manage, troubleshoot it in the event something happens to not work like it's supposed to at some point in time. So next slide. Where's IBM going with this, and why are we doing this, and what's the overall business value that customers see? Because a lot of folks have already gone down a path of doing this. The goal here is to drive a single, holistic approach that gets your arms around storage. The goal of this thing, in real simple terms, is to lower your storage run rate, drive out costs, drive out complexity, give you choice, increase availability. What we've done with that is, in addition to just virtualizing storage, which in and of itself is a relatively simple concept, what we're doing with that to really change the cost curve and where we really differentiate ourselves from our competitors out there is we have been integrating a lot of storage efficiency and optimization technology into our solution. We're going to talk about inline real-time compression today. We're going to talk about right tiering and auto tiering and a variety of things in that area as we're doing it. What we've been doing is, in the overall IBM construct, has actually been taking a lot of our own research projects, and when we get into the storage analytics discussion, we're going to talk about where we took a project that IBM developed internally for self-preservation for our own 10-plus petabyte U.S. storage infrastructure, and we've taken it, drove $90 million of cost out of IBM's infrastructure, and took that same technology, and we productized it and are putting it in our virtual storage center solution. We'll talk about that as we go forward with here. In the overall construct, you're going to hear the term SmartCloud Virtual Storage mentioned, or VSC. That is the component of the package that you buy. It includes several things underneath it, such as it includes the technology to manage your SAN and your storage resource management. It includes the technology that allows you to virtualize your storage. It also includes the ability in it to make application-specific snapshots to get yourself into a rapid hardware-assisted backup and restore type of environment. Specifically the components under the covers of it that make up virtual storage, and that we'll talk about in a little bit of detail here. As far as the storage resource management technology and the analytics, that's the Tivoli Productivity Center, TPC component. The virtualization layer is IBM SAN Volume Controller, been around for 10 years, about 75-80% market share out there in this space. And then we'll talk about Flash Copy Manager a little bit, which is the actual component that goes in and does application-aware snapshots, lets you make those snapshots, as well as facilitate the rapid restoration of that data at the application layer should you need to do all that stuff. All in a simple, easy-to-consume package. Go ahead. In terms of Virtual Storage Center, what are the kind of things you can do with it in real simple terms? First of all, we're going to start realizing, and we'll go through this in a little bit of detail, how you can, once you have it in place, you can now start pooling physical storage. They can be typically as multiple arrays. They don't have to be, but they can be from multiple different vendors. And once I start pooling things together, I'm going to start to be able to take advantage of optimization plays, such as storage pooling, then provisioning, right tiering, real-time compression that I can start to apply to an environment. We're also going to find that we're now bringing in a set of enterprise-class storage functionality that I can apply across my entire environment, whether I've got this from one vendor or 10 vendors, whether that vendor has function in it or not is irrelevant. We're going to learn and see that what SPC does, it commoditizes the back-end disk array by moving the smarts, the enterprise-class functionality, up into the hypervisor layer. Again, allow me to apply function no matter what my back-end disk is and do things between vendors regardless of what I've got on the floor. Once I have things in place, we're going to start seeing that we have data mobility. And data mobility used to be just moving data from point A to point B, typically when I was retiring a storage asset to avoid all the complexity associated with that. But these days, mobility is also used to right-size your environment, i.e. get things on the right tier at the right time. Again, letting me get away with more lower-cost storage when and where that makes sense in my environment. Lets me start moving things around, start exploiting flash or solid-state type technology when and where that makes sense in my environment, as well as doing it to troubleshoot problems and so on and so forth. If I've got a performance problem moving data around to address that dynamically on the fly without impacting my production environment. Once I have all this in place, I'm going to obviously need some very strong, robust, and you'll see some Gartner Magic Quadrant centralized storage management technology to address all that stuff, to make it simple, easy, and efficient to operate and manage, as well as putting in place all the kind of tools and information you would need to turn this into a storage as a service type mindset. A lot of customers these days that have never done chargeback or showback, I'm seeing them want to move toward that model to where the user no longer dictates what it is they have to have specifically, but instead they're going to sign up and basically pay for a service or a set of services. And what starts to become important here is the ability to provide chargeback or at a minimum showback capabilities, so that when that user says, I've got to have my file server on that flash storage device, you can say, okay, that's going to cost you this. I think you could get away perfectly fine with something that costs half as much. Are you willing to pay for that type of stuff? Go ahead. In the context of pooling storage, again, the SAN volume controller, the hypervisor, we support approximately 175 different back-end storage devices, by far the broadest set of back-end support in the industry. I'm able to take storage from multiple places, pool them as I make sense. Of course, there are best practices involved in all that I'm not going to go into today in this introductory session. But I can certainly create storage pools based on performance, based on application needs, based on a variety of parameters that make sense. I can take storage from virtually any storage box out there in the industry, pool it however I make sense in there. This is one of the key things that comes into play, and one of the reasons we start to differentiate this type of technology from virtualizing things inside the array. An example being, we'll get into a little more discussion on some of the optimization technologies, but a lot of customers sit there and say, well, I've got my storage array, and I have thin provisioning in it. I can reduce my cost by doing that. The answer is, yeah, you can. But when your storage virtualization pool is tied inside the disk frame itself, what you can't do is you got to be a little cautious of how hard you drive your utilization rates. When I have my virtualization sitting above the storage arrays, in the event I now can afford to very comfortably run my arrays a little more aggressively, maybe run my pool 75 to 80% instead of 60, 65%, because I have the ability to react and adapt in a quick, timely, and easy manner in the event workload changes unexpectedly. I start to run out of space. So go ahead. Once I have this in place, what you're going to find out about the SVC in particular is it has, in fact, in some cases more, and in virtually every case the same, if not more, functionality than your enterprise-class disk arrays. We're going to learn about how it uses its cache to do things like read and write caching, which can be used to improve performance in a lot of environments. It's got function, it's got thin provisioning, and today a lot of arrays have that. We now can do that function again at the SVC layer, meaning I can drive my pools more aggressively than I could if I'm doing it in the back-end array typically. We're going to learn about auto-tiering. This is like moving sub-LUN level data to optimize for performance. We've got the ability to have point-in-time copies and remote replication, a very rich set of business continuity functions. And with the distinct advantage over enterprise-class arrays that my storage on each end doesn't have to be the same. I could have data living on an IBM DS8000 on one end and an EMC VNX on the other end if that's what my requirements warranted, and that was good enough for what I needed to do. I've got the ability to move things around dynamically on the fly as I see fit, as makes business and technical sense. Plus, I've got a unique feature called real-time compression that we'll talk about in a little more depth coming up on an upcoming slide, that in real simple terms allows you to cram more stuff into less space on the back end. And obviously, if you can do that, that typically drives cost out of your business equation. In terms of mobility, we used to think of mobility as one of the key things the SVC did. When, 10 years ago, everybody thought this one of the key value props of SVC was, well, if I have it in front of my disk array, when it's time to retire that asset, I can bring my new array in, move the data with no impact to the end user, pull my old array out. And you still can do that, in fact. Obviously, it's one of the key things you can do. But today, mobility has frankly become much more than just that particular function. We also got to think about moving data around to the right place to optimize performance, to troubleshoot problems. Over time, I can look at environments where I can transition storage environments from less $10 disk to more $2 disk over time. by using some intelligent analytics and the ability to move things where I need to dynamically and on the fly, as well as get myself in position to take advantage of things like auto-tiering and flash technology by allowing myself to get the right sub-LUN component or the entire LUN, if appropriate, up on that really fast flash technology to drive that latency out of my environment and optimize the performance of my environment. I also had the ability to do this. I have the ability to do this, A, within a physical data center, or B, I even had the ability to construct what we call an active data center, where I can take my SBC, stretch it up to 300 kilometers, and allow environments like VMware with their mobility function, AIX, dynamic LPAR mobility, and a few other applications trying to exploit the ability to move data and workloads dynamically between two local data centers without all the typical complexity associated with remote replication solutions. In terms of managing it, what you're going to learn and see as Chris does his demo is how simple and easy the environment is to configure, set up, maintain, but manage. What you're going to learn is no matter how many different storage arrays you have on the back end, from how many different vendors they happen to be from, you'll find that you'll be able to do 95, 98% of your day in, day out interaction at the SBC layer. It gives you that common look, feel, that centralized vision, end-to-end vision through it, to do all that stuff. What it's also going to do, it's not really part of the demo today given the time constraints, but what you're also going to see is that it is also the way you can set up portals to get into doing things like automated storage provisioning, which a lot of customers are looking at getting into these days. One of the key things that typically comes out in the business case when you start looking at should I virtualize my storage or not is how do I drive cost out of the equation to get my arms around my environment. Fundamentally, there's four pieces of technology that end up doing the bulk of that when you start looking at a virtual storage center. The first is storage pooling in and of itself. If I'm managing a large pool versus a set of small pools, obviously I'm able to drive my utilization rates higher and I end up with less orphan storage or wasted space. On top of all that, the technologies that come into play here, first of all, you have thin provisioning technology. Thin provisioning allows you to only allocate the data that's been written to the virtual volume. A lot of storage arrays have now embedded that function inside their environment. Some applications have even started to put that function at the operating system. But certainly you have that kind of functionality where appropriate to not write all those binary zeros out there to the back end of the environment. We also have the ability to optimize for performance, and this is what we're talking about easy tier. This is our auto tiering technology that at a sub-LUN level will dynamically monitor and move the portions of a volume that would benefit from being on faster disk up to the faster disk. It's simple, dynamic, on the fly. It assumes a higher level of solid state or flash, even though it doesn't technically have to be. And what we're going to find that it does, it allows you to get away, again, in terms of driving cost with less robust back-end disk behind it, and it lets you utilize that relatively expensive flash disk very efficiently by identifying the components that are being the repetitive random read portions of your environment and getting them onto that to optimize the performance. The Storage Analytics Engine, or SAGE as we like to call it, was work developed out of IBM Research a couple years ago. It has now become part of the TPC product. This is right tiering at the virtual volume level. The goal of SAGE is to let a customer environment go from having a certain mix of $10, $5, and $2 disks that over time you increase the amount of $2 disk and reduce the amount of $5 and $10 disk you have in your environment. You sit there and say, how the heck do you do that? Well, first of all, and go ahead to the next slide, Sue. What you're going to see here, what the Storage Analytics Engine does, underneath it you basically define various tiers. And this is showing an example with, say, solid state or flash, say with 15K drives and nearline SAS or ATA drives in my three pools on the right side of this chart. What you basically do with this thing is the performance tools collect a lot of performance data against this environment. If you had time and the inclination and the smarts, you could certainly analyze all that stuff and figure out what volume made sense to put where in your environment. The problem is most folks don't have the bandwidth and the resources to go do that. So what you can do is as simple as saying, I've got a list of volumes. I want to consider them as being down tier to my bronze pool. I want to look at 45 days worth of performance data, and if the IU rate is less than, say 15 IOs per second, give me a list of recommendations of who I should move down. What you typically do in real life is very conservatively move things down, and then very aggressively, say at one-day intervals, move things back up to the higher tiers. What this allows you to do is over time, over a tech refresh cycle, transition an environment to a larger amount of $2 disk in my example and a lot less $5 and $10 disk over time, with the knowledge and sanity behind that what you're doing is really the right thing to do and it's going to perform quite well. We also have a lot of very robust business continuity function built into the SBC. Specifically, if you have multiple sites that need disaster recovery, we have the ability to do synchronous replication. We call that Metro Mirror. We have also got the ability to do asynchronous replication. We call that Global Mirror. A couple flavors of that, in fact. One, if you've got a very robust pipe amount of bandwidth. The other, if your bandwidth is somewhat constrained. We have the ability to do more of a classic DR scenario between two different sites when and where that makes sense in your environment. What's unique to this technology versus doing it in the traditional array is that my disk arrays can be from different vendors or different types of array on each end. I could have an IBM DS8000 at my primary site, and I could have an IBM B7000 at my DR site, and I could do my replication between those with no care whatsoever. I also have the ability to make application-specific aware backups for SAP, DB2, SQL, Oracle, Exchange, and VMware. What this does, it allows me to minimize the risk of my data loss and allows me to start to deliver premium levels of recoverability to my applications. I run into a lot of customers these days that have 5, 10, 20 terabyte databases or large VMware data stores for that matter. And in the event of a disaster, the problem is it's going to take them multiple hours potentially to recover that stuff from tape. The business can't tolerate that, can't handle it. So what they start looking at doing is technology like this that can restore an environment from a snapshot that lives out there on my back-end storage in order of seconds or minutes rather than hours or days if I had to pull that same environment back from tape. In terms of compression, one of the silver bullets of the technology and one of the unique features of the SBC, about 3 years ago, we bought IBM acquired a company called Storewise, who did at the time inline compression against file-serving environments, NFS-sys. We had an appliance we now call it the real-time compression appliance, or compression engine that has Ethernet ports. You sit between your Ethernet SAN and your file server, your N-Series or whatever brand of file server you may have, and it inline compresses your storage. We took that code, modified it, and enhanced it to where it now works in a block storage environment, and we embedded it inside the SBC kernel. So it is actually part of the SAN volume controller software and kernel at the more current software releases. What this does, it allows you to inline compress active data and typically get 2, 3, 4, sometimes 5 to 1 type of compression ratios. What that means, of course, is I may be able to get away with significantly less storage. A little disclaimer, and to put it more in context, does RTC apply to every single bit of storage in your environment? The answer is probably not. There's probably some data you have that doesn't compress very well, and there's a couple of workloads that might not be best suited for the environment. We typically find is that in most environments it applies to anywhere from half to 2/3 of your environment, giving you somewhere typically between 2 and 4 to 1 compression ratios against the environment that it makes sense at. Where do I see folks? Go ahead. Where do I see folks starting to work with this in their environments today? Typically file share environments, test dev copies of databases, and VMware farms are probably the main places I see folks doing it. Can you do it against other environments? The answer is absolutely yes. But again, that's kind of the sweet spot and where I see folks tend to start with it. This technology has been out in the SBC now for about a year. We've got a lot of experience with customers doing it. This chart just shows you some typical compression ratios that customers see for various environments, anywhere typically from 30-40% on the low end to 80-90% on the high end in some scenarios. And you see, of course, that there's a wide range based on what you're actually doing in the environment. It isn't as much guesswork as it may sound. We do have a very simple, easy-to-use tool that you can download for free called the Comprestimator. And when you have that, it will give you, in about 2 minutes, an estimate of how much an individual server's data can be compressed to let you identify the optimal candidates to run for your environment. There's also quite a few best practice documents out on this technology now that obviously I would encourage you, and Chris and his team would work with you on to make sure you understood before you deployed it on any significant scale to get the maximum bang for the buck out of it. In terms of cloud and storage automation, storage provisioning, if your environment is large enough that you're looking to get into self-service portals or to automate the storage provisioning process on top of your server provisioning process, the APIs needed to do that entire environment have been incorporated into our TPC product. There is upstream integration into other IBM SmartCloud orchestration and provisioning products as well. You certainly could write the integration from other vendors' products as well. The key point here is, and I've seen several of our larger customers already start to do this, is if you want to get to the point of creating like a self-service portal to provision your storage, think of it as having that screen where you may type in 4 or 5 lines and then pull 4 or 5 other items from drop-down menus and hit the enter key. That capability is fully there. The SVC technology was designed from the ground up to support that, and we've integrated it completely into the Virtual Storage Center product. So, one of the oxymorons that folks ask me all the time, in fact, 10 years ago I asked the same question of the developers. I said, you're going to take this server, this thing, stick it in between my server and my storage and not expect it to slow down things or improve performance? How the heck does it do that? Well, fundamentally, the reason it improves performance in the environment is 2 or 3 things. First of all, it's got cache in it, and it's using the cache for reads and writes the same way a disk controller does. So environments that are sequential read to cache in the controller is going to be prefetching data into the SVC, so you get your read responses coming from cache. Some environments, some IOs are going to be read misses, and they'll have about a 50 microsecond latency penalty associated with that. For writes, we certainly use the cache to buffer the writes and try to destage them in a more elegant manner than you would if you flow the data straight to the back-end storage. What you typically see is that, coupled with the fact the way we're doing the prefetching and the way we're coalescing the writes in the back end, in this example, what you typically see is that the way we improve performance on disk controllers, in addition to the cache layer, is by having the cache do what it does, we're able to typically reduce the amount of I/O that actually goes to the back end, fewer large block transactions rather than a lot of small block transactions to the back end. That makes a big difference on mid-range controllers, and it can make a difference even on enterprise class controllers as well. Okay. A lot of you out there may well have implemented VMware for your server environment, and may even be some of you may even be the VMware storage admins. We have a full, very rich integration with VMware in our product. We have full integration for the VAAI support, been there for about 3 years now. The Write Same, Atomic Test Set, and Xcopy primitives have all been supported for several years. If you're doing DR with VMware using Site Recovery Manager, we have the SRAs, the plugins available to plug in with that. And then if you want to manage your storage from vCenter as opposed to from the SVC, and I have some customers that do want to do that, we have a free vCenter plugin that you'd be able to use to plug it into vCenter that can then manage and provision your storage behind the SVC from the vCenter environment, if that's how you want to run your shop. Okay. Also quite common with VMware environments today, or with customers that have more than one data center in a metropolitan area with high bandwidth between them, is creating what we call an active-active data center, where you're taking your logical cluster, your IP network, and your storage and stretching it between 2 different sites. You'll hear various terms mentioned to it. We call this a stretch cluster with our technology. We've supported it for several years. It integrates very cleanly and well with VMware and AIX. We, in fact, have recently published red books with detailed examples and case studies for both VMware and Power. We support that environment up to 300 kilometers should you have an environment that goes that far. Do folks really run it at 300 kilometers? No, because latency tends to come into play by the time you get out to typically 70, 80, 90, 100 miles in distance between the 2 sites. But we have that capability. What's also unique about us compared to our competitors, who also may be able to stretch an environment, is we do not require any additional bolt-on product into our solution to also add a remote replication to the environment. That's simply a software feature of the SVC. You just turn it on if that's what you need to do on top of your stretching the environment. Our competitors are going to require you to have a separate bolt-on appliance to do replication on top of the appliance they would put in there to do the actual stretching between data centers. In general terms, why do folks do this, and what is the value prop they see out of virtualizing their storage? In general, the reason you're doing this, I would say it gets your arms around the spin, sprawl, complexity associated with your storage environment, but it should drive, this really should drive down your overall storage spend and run rate over time when taking advantage of the capabilities there. It's going to give you an opportunity to drive up storage utilization. Not uncommon to find customers running 60, 70, even 75% utilization on their storage. And I don't mean allocated the way some vendors like to talk about it. I mean for every 100 terabytes of storage you have out there, you've got 75 terabytes of stuff sitting on it, that's data that should actually be out there. So we're able to do that to drive up utilization, which of course defers purchases or means you need to buy less going forward. You're going to also be able to typically drive up availability. How do you do that? By being able to move things around and avoid a lot of things today that are planned outages for a variety of reasons. I'm going to be able to manage my environment much simpler, much less complexity. Again, as this thing scales, it is no harder to manage 2 petabytes than it is 250 terabytes in an environment with this technology. It's the same exact skill set and the same amount of effort to do all that stuff. And I'm now giving myself a lot of choice and flexibility. I have commoditized my back-end disk. I can replicate between different brands and types of disk if I want to. So I've got a lot of flexibility that opens up the door. In fact, I had one customer in Georgia who told me that the day he put SBC in front of his HP storage, in this case, the price of his HP storage arrays went down 25% overnight. Because now he could compete those out there, and his price for everything went down dramatically. This is a sample business case. If I told you this customer was, this is actually a Fortune 100 customer, and if I told you who this was, you guys would all know it. Of course, I zeroed out and marked out all the numbers. This customer actually has about 5 or 6 petabytes in their environment, heavily Tier 2 versus Tier 1 storage, mainly EMC in their case. And we were looking at virtualizing it and driving up utilization rates over their 5-year tech refresh cycle. This chart is typical of the charts you see when you do the business case. And again, our friends at MicroStrategy, as well as your IBM reps, have the ability to run these type of ROI analysis against your environment to figure out where you're from, where you're going to. What typically comes out of these things is the break-even point is between 6 and 18 months, usually more like 9 to 12 months, but obviously actual numbers vary. The ROI is typically between 200 and 500% ROI. Again, that depends on where you're coming back in this environment, and where you're coming from and going to in your environment. So very simple, easy to do, doesn't take much time. And again, MicroStrategy can do this with you, or your IBM team can also assist you with doing this, typically at no cost. About a few years ago, we actually pointed a Forrester at a bunch of our existing SBC customers and told them to go ask them a simple question, which was, did you get your money's worth out of buying this virtualization technology from IBM? And what Forrester came back with was the average improvements and the average bang for the buck customers got was these across the environment. These customers were typically in the order of 200, 300 terabytes at the small end to about 1 to 2 petabytes at the high end as far as how big they were size-wise. Typically what we found was customers were able to double the efficiency of their storage administration staff. It doesn't mean you get to get rid of somebody, but it means that person gets more hours back, as well as the ability to do things that might be of additional value to your organization. We typically see they drove up the utilization of their storage. When I say by 30%, that says go from 40% to say 60% is about a 30% increase. But whatever the numbers may be, but they typically drove utilization, meaning they needed to buy less storage going forward. They're able to reduce their cost storage run rate by about 20% on average. That comes from a variety of things we talked about, as well as they were able to typically drive up availability and improve the end user satisfaction because they're able to avoid a lot of things that typically had to be done. Things like being able to move data tonight versus having to wait till the weekend to get it done, and do it without an outage to the application versus coordinating an outage among 15, 20, 30, 40 end users who have totally different needs and requirements. a couple of case studies. A couple of these, and this customer actually was actually one of the presenters at Edge actually last week in Las Vegas, for any of you that happened to be able to attend. But Ricoh was one of the first SBC users back, and they started back in 2004. And in fact, they told their 2004 to now case study history out at Edge actually. But they basically adopted it back then when they were about 200 terabytes in size. Today they're about 2 petabytes or so in size. They feel they would be about 3.5 to 4 petabytes if they did not deploy SBC today, by the way, as a compare and a contrast. Basically what they've done, they had 2 storage admins managing 200 terabytes back in 2004. They've got 2 storage admins managing 2 petabytes right now, and they feel there's no reason those same 2 folks couldn't manage 5 or 10 petabytes if they needed to or had to. They've now implemented during this time, they went through an acquisition and integrated another entire data center with different vendor technology under the SBC in that environment. During this time, they've done all that stuff. So a very, very strong, compelling case study, and we can talk to you more about that if you'd like. There's a link out here to a YouTube. Marty Everett, who was the guy who made the decision back in 2004, has gone ahead and published a YouTube that you can see on the link on this chart, where he'll tell you the general gist of what they did and why they did it and the value they've seen out of this technology. Another case study here is a simple one. It's IBM. Of course, we drink our own champagne. I got told years ago to stop saying eat your own dog food. So now I tell everybody we drink our own champagne. But IBM, everything I've talked about here with Virtual Storage Center, IBM does internally. IBM's U.S. storage infrastructure is approximately 10 petabytes in size. You want to know how big it is? It's much bigger than that when you count Europe and Asia and other places. That is just block disk storage. We also have some file storage and tape on top of all that. Every single bit of IBM's open system storage happens to run behind SBC. We do have some mainframe, believe it or not, in IBM, and it is outside SBC because we're talking open system technology here. What IBM did, we were forced to try to drive cost out of our storage environment. Back in 2008, 2009, IBM's storage environment was about 75% enterprise class storage, about 25% lower cost storage, a couple of variables in there on top of that. Today, IBM storage is about 5% flash, 20% enterprise DS8, 20% XIV, and 50+% mid-range storage. How do we do all that stuff? We develop the analytics to analyze our data, right tier the environment, as well as grow utilization rates up. What we've seen in IBM is it reduced our average acquisition cost per terabyte by about 50%. The first 3 years of the project saved over $13 million. The number should be approaching $85 to $90 million by the time they complete the entire tech refresh cycle at the end of in the middle of 2015. Those are the kind of numbers you can get out of all this stuff. Next slide. And you sit there and say, how do you tier? This is back to the storage analytics engine I talked about. And this is these charts on the right are actually IBM's internal storage for the U.S. back circa 2008-9 and versus how it is today, basically, showing you basically the percentage of mix that IBM has in all of our environments. This is what we did. We used to always throw things at the enterprise class storage because we knew it would run there. Of course, then somebody said, you can't afford to keep running it all there. Figure out how to make better use of what you've got, right? I'm going to reduce your storage budget. And we then developed, go ahead to the next slide, which we did. We basically developed the analytics engine, which is part of Virtual Storage Center. It was developed internally as a research project and is now being put into the IBM products for customers to use. I've already got a lot of customers using this stuff very, very effectively. And what you're able to do is, in real simple terms, you define some performance criteria, and you start picking volumes. I want to consider them to be up-tiered or down-tiered to a various storage pool, and it will then do the analytics, the analysis, and give you recommendations of what it thinks you should move or shouldn't move between the places you identify to it. Makes that process very simple and very straightforward. In fact, IBM these days automatically moves about 60 to 70 terabytes a week around within IBM's 10 petabyte infrastructure, automatic in an automated manner. Obviously, that took a while to get to that process versus doing it on day one. So go on to the next slide. There are a lot of customers, some small, some medium, some large. I'm sure from this list, I actually went and counted before we started here. I've actually had the pleasure of working firsthand with 14 of these customers on this chart, actually. But again, a lot of these are names that you know and understand. This technology has been around in the marketplace for about 10 years, that the SBC has. Some of the more recent enhancements, things like compression and the analytics, are in the last 12 to 18 months. But the technology has been out there. There's about 8,000 to 10,000 SBC customers, depending on how you want to count that in the world. Plenty of folks doing it. Some small, some medium, some large. I'm sure some in every one industry you've got out there. If, as you start looking at this technology, you'd like to have a conversation with somebody that's doing it, the simple question typically that I ask you is, what do you want to get out of the conversation? So make sure we take you to the right people. Plenty of folks doing this. MicroStrategy's got a lot of experience implementing it. They have a lot of customers using it, and obviously we have others out beyond them that are as well. So plenty of folks doing this stuff, widely used, widely deployed. Go ahead and hit the enter key twice to build it up. One more. There we go. From an operations perspective or from a management perspective, the management tool that would be used to manage the environment once it's put in place is called Tivoli Storage Productivity Center, or TPC. TPC has several things in it that are parts of it. First of all, it has the basic end-to-end visualization capabilities throughout the environment. So once I deploy this virtualized environment, I'll be able to see from the server through the SAN to the virtualization layer, through the SAN to the back-end disk array. I'll have a visual picture. I'll be able to see performance metrics at every step throughout the way, and a variety of other information as well. I'm going to be able to do performance monitoring of the environment, both and from the SBC view on the server side and the back-end side, to tell where my bottleneck is in the event I happen to ever find one or have one. But I'll be able to troubleshoot the environment end-to-end, both to monitor it as well as generate alerts and various messages in the event alerts are triggered. I have the ability to do the same thing for my SAN fabric. I have the ability to do my provisioning from TPC if I want to, but typically we find that's more for automated end-to-end provisioning, as we talked about with the cloud APIs earlier. I also have the ability to set up, maintain, and manage my DR, my replication capability. It's all part of the product. And then I have, on top of all that, what comes with Virtual Storage Center specifically are typically a variety of optimization analytics. The storage analytics engine I talked about is part of all that. Some tools that let me do some other planning as well as performance optimization capabilities and monitor my changes that have occurred in my storage environment are all included in it. Next slide, please. The one other component that is part of all this is for application-aware snapshots. It's called Flash Copy Manager. It will have a plug-in that runs on Oracle DB2, SAP SQL Exchange, or VMware. It will then allow me to take application-aware copies. This example shows 3 copies being made. They can be full clones, they can be incrementals, they can be snaps, they can be whatever you want them to be based on your use case. Once I have made my copies, I can then have the ability to quickly restore, do a reverse flash copy, so to speak, or a flashback, and I can turn around and restore any one of those copies back to the application to get the application back up and running off that copy of data in a matter of seconds. Also, once I have my copies made, if I'm using TSM as my backup recovery tool for long-term DR, I can take these copies and pass them back to TSM and manage them in my TSM hierarchy for long-term DR and retention. Okay. Trying to summarize the value that Virtual Storage Center or SBC brings to most environments. First of all, typically we're going to find that it drives down your overall storage run rate 20, 30, 40% in most cases. It lets you start doing things during the day, like moving data around, that today requires downtime, off-shift work, weekend works. In many cases, you'll find that the cost that you today have to spend buying business continuity function on your disk arrays now becomes a recurring stream at the SBC list. So I may have buying as much of it as I need and use versus buying it for the box just because I bought the box. But more importantly, when I refresh my back-end disk array, I no longer need to buy the function again. A lot of high-end disk arrays, you'll find that once you take off all that advanced function, the cost of that array gets cut in half. Half the money you might spend on an enterprise-class array is on the business continuity function and the maintenance associated with that versus just the hardware. We're able to leverage your existing storage investments, so this is not going to require you to rip and replace your current storage infrastructure. We have the ability over time to transition you to an environment that is doing more tiering than you might be doing today. Again, get into an environment with more $2 disk and less $5 and $10 disks as you go through a tech refresh cycle. Your storage admins will typically love you when you invest in this technology because they now get most of their nights and weekends back, because typically the only thing we ever recommend you do with an SBC off shifts or on weekends is a code upgrade, and we all know that's always a risky thing for anybody's box, let alone an SBC, right? When you change things, you want to get that. In terms of open management, we're able, with TPC, we can certainly manage non-IBM storage using open SNIA SMIS standards, so it doesn't work with just IBM. From an availability perspective, again, you'll be able to move things around during the hours, add in capacity, change the infrastructure, etc. In fact, one of the proof points that IBM used, it used to take IBM on average 235 hours of work to retire a disk array. Now it takes 6, because all that's behind the SBC. There's no longer the planning, the coordination efforts required when it's time to actually retire a disk array. Again, drive up storage utilization, and in most environments, it will actually help performance of the environment, particularly for mid-range box, but even will help enterprise-class arrays to a small degree. So next slide, which I think is that. So with that said, we'll be back. I'll be back in a few minutes for Q&A, and we're going to let Chris do a demo of some of the technology for you for the next few minutes.
Okay, thanks, Gary. What we're going to go over is pieces of Virtual Storage Center. We're going to talk about the SPC, the SAN volume controller, and we're going to demo, TPC, or typically Productivity Center. With Flash Copy Manager, there's many versions depending on the database, so in the interest of time, we'll just stick with the two main pieces. Okay, sorry. So this is the initial screen on the SAN volume controller. Since it came out 10 years ago, it's had a couple different iterations of the screen. Everything has moved more towards the XIV version of the graphical user interface. If anyone has an XIV, this would all look familiar to you. So actually, all of IBM's storage products now have a screen similar to this one that you're seeing now, which makes it easier to manage the different varieties of storage products that you have. This main screen is an overview, and Gary went over a little bit of this, but just a little deeper explanation. If we start at the left, I have two external storage subsystems that I'm virtualizing here, and as we'll see, they're an XIV and the DS5000. When you create volumes from the storage systems, they're presented up to the SAN volume controller. The storage thinks that the SAN volume controller is the host. So they're presented up and they're called MDIS, and then they're pooled together. We have 5 pools. These pools are divided up by disk size, as we'll see, and out of them we have 260 virtual volumes that are presented out to 46 fiber channel hosts and also 1 iSCSI host. The newer nodes and SAN volume controllers support both 1 gig and 10 gig iSCSI. So moving along, just a brief overview of the system. As you can see here, we have 2 nodes in our SAN volume controller. That's called an I/O group. They always come in pairs because they talk to each other. They're there for redundancy. A SAN volume controller can grow out to 4 I/O groups, or a total of 8 nodes as your environment grows. Off to the left, you can see the allocation view. Currently, we have 13.59 terabytes allocated. Now, we're also using compression that was talked about earlier. And from this screen, we can fly over and see that what we're using, or the space that we're saving just by compression, using compression. Also added into the newer version, this version that you're seeing is some performance statistics. This is a good screen to review. In the middle of the day, you have an application. They say they're experiencing a problem. They're probably going to blame it on storage, as we see they normally do. This is a good place to look for real time. This will keep the last 5 minutes. This does not keep any historical data, but as you can see, it gives you some of the really key information. Our CPU utilization on the nodes is minimal. what are my volumes doing? Read, write. If you want to put latency in there, you can put latency. My interfaces, what's my fiber channel doing? We are a lab, we're not doing anything extensive here. And also the managed disk in the back. So how is the SAN volume controller nodes performing V-staging that data to the back-end disk? You can look at that in IOPS, you can look at that in megabytes per second, and then you could also go and look at one individual node if you wanted to, if you thought there was just an issue with one node. Now, as we saw in the beginning, there was external storage and internal storage, just so there's no confusion. The IBM V7000 also runs the same exact code that the SVC runs. The V7000 does support internal disks. So as you're looking at this interface, the way to tell if you're in a SAN volume controller or a V7000, besides what it says in the top left, is if it did have internal disk, then we would know that it was a V7000. So here's my two external storage arrays. As I said, I have a DS5000, which has both fiber channel and SATA drives, and then I have an IBM XIV. And these are the disks that are presented up to the SAN volume controller. And what we do is we take that data, those LUNs, after they're sent up as managed disks, and we put them into pools. Our pools here, in the DS5000, we have fiber channel drives, we have SATA drives. You're not going to mix and match them in the same pool. You're going to try to keep like drive, speed, size, and parity in the same pool. So we have a fiber channel pool, a SATA pool, and then two pools out of our XIV. So really you can consider the XIV Tier 1, the fiber channel DS5000 Tier 1 or 2, and then the SATA Tier 3. And then in each pool, there's virtual disks that are carved out of them and presented to the host, and we're going to go over how that happens in a minute. If you wanted to know out of a particular pool what volumes are presented, you can go and look through these lists right here if you want to see what was in SATA, etc. Tells you up on the top how much is allocated out of what's available in the pool, as well as any compression savings if you're compressing volumes within that pool. So volumes, after you do the initial configuration of the SVC, you present all your storage up to it, you put it in the pools. This is pretty much where you're going to spend your day. Daily operations, everyone's always asking for more storage. This is where you're going to do it. As you can see, we have a lot of volumes here. Just a brief overview. The volumes online, this little dumbbell here, whatever you want to call it, showing that this is actually a compressed volume. You can tell they're compressed if you look at the savings, and it actually tells you on each volume what percentage you're saving by compressing, in both in percentage and gigabyte. And there is actually a tool that you can download from IBM, and Gary, I didn't hear if you mentioned this or not, called Comprestimator, where you can run Comprestimator on your host, point it at the volumes that are assigned to that host, and it will give you an estimate of how much you would expect that volume to compress if you put it behind the SVC and turn on compression. And it's accurate, plus or minus 5%. So it's a pretty good tool. Tells you what pool it comes out of, unit ID in case you had to follow it back to the storage, and whether it's mapped to a host or not. So what I am going to do is create a new volume just to show you how easy it is once you have your storage all configured. You click on new volume and it comes up with a couple options. You have generic, which is a average everyday run, thin provision. Obviously we're going to give the host X amount, but only give him a portion of that he's going to use. Mirroring is a very neat option. You can create a volume and then mirror that volume as a RAID 1 type mirror to another storage array behind the SAN volume controller. thin mirror is a mirror that's thin provisioned, and then there's compressed. On the bottom here, you can see the pools that I have an option of creating from. Tells you how much capacity is in the pool and free capacity. So we'll pick an XIV pool, and we'll call the volume WebEx. And make it 10 gig. You have a bunch of different options. You can go up to terabytes. You can start at bytes. Why bytes, I don't know. But if you wanted to create more than one, you can just create on add volumes, and it'll actually append the number on the end. Now, if I click on the advanced option, okay, this is where you can go in and kind of change some of the presets that are put in by the code. You can change the preferred node that the volume is going to be presented to. You can format it before use. Capacity manage. We told it we wanted generic, but if you wanted to make it thin provision, you can do that. Tell it how much or what percentage of the virtual capacity you want to make available. Automatically expand it if it reaches the limit. That way it won't go offline, and send me a warning at if I reach say 75%, because if you are thin provisioning, you have to start managing a little better, because you're over provisioning what you have and you might be running out of space. If you wanted to compress it, you can make it a compressed volume, and then there's also the mirror option, which we'll see in a little bit. So what we're going to do is create and map that to a host. Now, as you can see here, this screen coming up for all of you CLI lovers, this is the actual CLI command that you would type to create the volume that I just created. This can all be scripted. You can cut and paste this out of there if you needed any help for it. There's red books on how to do that. Since we told it we wanted to map it to a host, okay, here's all of our hosts that are defined in the SVC. We'll pick a host that's coming in. He has a boot one because this is a blade that's booting from SAN through the SAN buying controller, and now we're going to attach that volume. And that's it. That's done. We just presented a 10 gigabyte, thinly provisioned, compressed volume to that host. If it's a Windows host and you go out to disk management and scan, it'll now be there to use. AIX, run config manager, etc., whatever your operating system may be. So now that that's done, that's nice, but let's see the other things that we can do. There's a good filter option up here, so we can search through and find just that run. If you click on it, you'll see that actions lit up here. We can map it to a host from here if we wanted to. We already have. We can unmap it if we wanted to. You can click on it, tell me what host am I viewed to, and it should come up and or map to. It should come up and say HS21, which is right. Move to another I/O group. If we did have another set of nodes and we wanted to move it over to that set of nodes, we could do that. You can rename it here. All that does is change the name for management. It doesn't affect what the host sees it as. You can shrink it. Not a recommended option, because if there's data on it, you will lose that data, but you can shrink it. But you can expand it also. Now, this is something we can do on the fly. So it's, currently 10 gigabytes. We want to make it 15 gigabytes, or 25. We'll expand it by 15. Say expand. Now that's done. If you go to your host and you rescan, you will see that there is a contiguous, a contiguous 15 gig added on to the end of that volume. As you can see, the capacity here says it's now 25. We can migrate it to another pool. So we had built it in the XIV, and we said, you know what? That was really the wrong storage for that. It should be in the DS5000. And it is now on its way over to the DS5000 an extended time. This can all be done while the host is up and running, applications are running, be it a database, web server, doesn't matter. 24 hours a day, 7 days a week. So that's really a key function of the SVC. There are people who actually have put SAN volume controllers in place just for migration. We recently migrated a customer about 1 petabyte of data in 5 to 6 days, just migrating 24 hours a day. Not one application complained, no host were affected. So as it's on its way over to another pool, we could delete it. We don't want to do that. But we can also create a mirror copy of it. So the mirror copy you can create is just generic, thin provision, or compressed. That's a way, if it was a generic copy and you mirrored it to thin provision, you can now go thick to thin. If you had a generic copy and wanted it compressed, you can now go thick to compressed. We'll say we wanted to copy that to this pool. And it is now making a RAID 1 copy of that volume. When that copy is done, you can do whatever you want with that. You can leave that for redundancy. You can split that copy, make the secondary copy now the primary. You can mount it to another host, do whatever you want with it. So speaking of hosts, defining a host in the SVC is very easy. Once you rack your host and put the fiber channel cables in and plug it in and you do your zoning, at that point, when you go in to create a host, those worldwide names, if your zoning was done correctly, would show up right here. You would just click on them and add the port to the list, tell it what kind of host type it is. Not a lot of options. Generic is pretty much everything. If you're attached to HPUX, because of the way their fiber channel works, you would select that, or BMS, or if you had an airline migration or ticketing system. Same thing with the host. If you select it and you go to Actions, it'll give you some options. You can look at the properties. Here's my host ID. It's offline right now. Do I have volumes mapped to it? Yes, I do. Here's the volume name. What are my port definitions? What fiber channel ports do I have defined? So here's the actual worldwide name. This happens to be an AIX host. These are MPIB IDs. So a lot of good information that you can get from here. Copy services, flash copy. Gary did speak about flash copy. We did talk about flash copy manager. Flash copy is a point-in-time copy. Takes approximately a second to take that picture, and then at that point, it'll do the background copy in the back end. What Flash Copy Manager does is you install on the host where you have your database, because if you just did a flash copy of a volume, it's really a dirty copy, because if there's a database on there, you're not stopping IOs from going through cache. You could have logs that made it across prior to the data making it across if you had some type of issue. So Flash Copy Manager will actually quiesce that database for the second that the flash copy is taking place. You can do a snapshot. Snapshot is just a bitmap image, doesn't use a lot of space, doesn't take a lot of time. We now have a snapshot of our volume. We can mount that to another host if we want. We can do a full volume copy. And as you can see, you can make multiple copies of different varieties of what you want to do, what you want to use your copy for. consistency groups are just if you have multiple volumes attached to an application and you're performing flash copies, you want them all taken at the same time. All you do is group those different flash copy pairs together, and it'll snap them all at the same time. Real quick, defining users in the SVC. This is a web-based environment. You have a lot of different options. You can make people just monitor so they can go in and look. Can't do anything dangerous, all the way up to you can be very dangerous and hope he knows what he's doing. Can be added into LDAP. Event notification, it will call home to IBM. It will also send people in your company if you want different emails letting you know what's going on. Fiber channel, iSCSI definitions are relatively easy. And last but not least, date and time, you can connect to an NTP server. You can do software upgrades right from here. As you can see, we're down leveled. There's a new version that came out just this week that I haven't put on yet. You can actually check for the updates from here. It'll download it, launch the upgrade wizard, and perform the entire upgrade right from the screen. The beauty of the upgrade is it'll do a node at a time. It'll wait in between nodes for multi-pathing software to recover, and it'll step through each node all the way up through 8 without affecting any operations. Okay, so that's a quick overview of the SVC. Just real quick, TPC, wrong version. Gary had talked about this earlier. This is Tivoli Productivity Center. This is the dashboard version. This TPC today has 2 pieces. There's a Java version and the dashboard. The dashboard is just for viewing and reporting, but it's a good step in the right direction. Watch the space. You're soon going to be able to do everything from here. Lots of good information from everybody from managers down to the technical folks. Quick overview of what your storage subsystem looks like. How much do I have in my pools? How much of it is file? How much of it is block? Has any of my jobs, collection jobs, failed? Servers, if you put agents out on the servers, you can actually collect file system data and file data and correlate that back to the storage arrays. And then when you do your reporting, it'll actually give you the ability to find orphan files, find duplicate files or files that haven't been backed up over a long time. And then you can just click on that and different things will come up over there. Just real quick on reporting, there are predefined reports. TPC now has Cognos built into it, so you have the option of looking at the combined reports or actually building your own. Let's take a couple seconds since we are in a lab environment. This is a neat report. Here's my volumes by space. It'll show you every volume that you have, how much you're using graphically, and then also down in all text information. And you can set this to run run once a day and email it to your manager or whoever you choose. So just a quick overview on reporting. And that is a very high-level overview of both TPC and the SAM volume controller.
Okay, great. Thank you, Chris. Appreciate it. We do have a couple of questions that came in, okay, as we were going through this. So at this point, I'll read out the questions and we'll get the appropriate person to answer this. I guess the first question we had come in was, with the storage analytics engine, to do the tiering, do I need to do this during an outage or a low activity period? Gary, can you answer that?
The analysis can be done at any time. It's just going to take historical data you've collected in TPC. You give it, for example, 45 days of time to go, how long you want it to go look at, and it will actually then give you a recommendation. It doesn't actually do the automated movement that's coming in the future release of the product. So then once you decide what you want to move, you then can do that at your leisure. SVC under the cover is a Linux kernel, and the data movement by default is at a very slow pace, meaning that your server I/O is not going to take precedent and it won't impact anything at all.
Okay. The next question we have is, do I need to wipe out my data on the array to virtualize it with the SVC and then reload it?
The answer is no. There's two ways you can get an application with existing data onto SVC. First thing you can do is you can maybe do a host-based migration. We see that commonly done like with VMware Storage vMotion as an example. So that's just doing the movement at the host level. The other way you do it, SVC has a unique feature called image mode that allows you to take the existing volume, virtualize it under SVC as it leaves the egg as an egg as it brings it in. Once you virtualize it and are accessing it through the SVC, you can then scramble the egg and place it into one of those storage pools that Chris showed you in the environment. So the impact of doing image mode, typically it's a reboot plus a few minutes. You got to log on and make sure that I gave Sue's volumes to Sue and Joe's volumes to Joe.
I guess that's what we would use to differentiate it between a gateway, where a gateway would have to really reload the data.
Yes. Yeah. Many of the other approaches require you to totally reload data. Either host-based migration or the data. SVC has an image mode technique that allows you to bring data into SVC, leaving it as is with minimal impact to the user, as well as I can use it to take data out of SVC with minimal impact to the application, should I choose to do so at some point in time.
Excellent. The next question comes in is, how many IPLs of my server do I need to do to put my server in front of the SVC?
Depends on usually one or two. It depends on the multipath driver you're coming from. Some multipath drivers like PowerPath might be down in the kernel. It might require 2 reboots to get done. Others typically 1. The reboot, if you're doing it, is typically to change the multipathing software from whatever you're running today to something that works with SVC. If you're using stuff like native MPIO, a reboot may not even be required at all.
Okay. And then I guess once I'm in front of that SVC, if I put any more storage behind it, I don't need any more IPLs.
That is true. I can do whatever I want behind the SVC, totally transparent to the server.
So once I'm in multipath set, I'm good to go.
Correct.
Thank you. And the last, I guess, was directed to the comment that Chris had made. Is Cognos and TPC a separate license, or is it bundled in?
No, it is not a separate license. It's all part of the TPC package as well as IBM DB2.
Okay. That was the last question I have. If there are no other questions, Sue, are there any other questions out there?
No.
That you can see? Okay, well, I'd really like to thank everybody for their time today. I found this session was very informative. Hopefully you did. What I would suggest, if there are any additional questions, feel free to reach out to me on my email at slicata, that's SLICATA, @microstrat.com, or you can reach me direct on my cell phone at 201-819-7373. At that point, I think we've covered everything we wanted to cover today, Sue.
Thank you, everybody. Thank you for attending.
Thank you.
Have a good day.